So the equation to find the volume of a cone, it can be listed a few different ways, but it's basically 1/3 the base times the height. Now, the base of a cone is a circle, so when we're looking at 1/3 of the base multiplied by the height, if the base is a circle, that means the area for the base is pi r squared. So it looks something like this, and then you multiply that by the height of the cone. This is basically what you got. So I'll just do problem number 2 here as the example for this first one. Look at what you got for a radius and look at what you got for a height. Sometimes they give you a diameter instead of a radius. So for example, if we were solving problem number 1, this shows 30 meters all the way across. Well, the radius here is actually equal to 15. And down here, they actually give us a radius and it's equal to 20, and they give us a height that's equal to 37. So I can plug those into my equation here. I got 1/3 times pi times r squared, so the radius here is 20 squared, and then multiplied by the height here, which is 37. You got to remember order of operations, so if you are going to make a mistake, or the most common mistakes I do see is sometimes people type this in a calculator, they go straight across. They do like 1/3 and pi, hit the parenthesis and 20, and then square it and parenthesis and 37. Dependent on the calculator you have or how you type it into the calculator, that can and cannot work, but what I suggest is solving those all in parts. So order of operations would say you do the exponents first, then we can multiply and or divide. Everything else is pretty much multiplication, so the only real critical part here is to make sure that you square the radius first. So I'm going to type in 20 squared. 20 squared gives me 400. And then now I got that times 37 times pi times 1/3. So again, that you can type in any order you would like. If I multiply 47 by 300, or sorry, 37 by 400, I get 14,800. I'm going to multiply that by pi. And then I'm going to divide that by 3. Multiplying by 1/3 is the same as dividing by 3. And you guys can definitely round your answers to the nearest whole number. Although you're in the ballpark, I mean, these numbers oftentimes are really large anyways. This gives me 15,498.5, so I'm going to round it to 15,499. And when you put the units, you got to look at whatever the units were measured in. So they might give you inches, they might give you centimeters, they might give you meters, they might give you feet. Just know that volume is a cubic whatever, a cubic yard, a cubic inch, whatever the measurements are. When the measurements are given, or if you're converting or measuring something, they have to be in the same units. I can't measure this in feet and this in inches and then get a result at the end because it won't work. These all got to be in the same units. So since we used inches and inches, this is going to be cubic inches for your resultant area here for this cone. So this is 15,499 inches to the third. Okay? There's an example for the volume of a cone. If you guys want to try solving that, check and see if you get your proper answer, then it'll be good practice. Okay? Next ones I'll show you is volumes of cylinders. So for cylinders, the volume of a cylinder is basically the base. They'll say it's the base times the height. But here again, your base of a cylinder is not square, it's a circle again. So you basically have pi r squared would give you the area of the base, and then you multiply that by the height. Okay? So again, be careful. We're dealing with radius and height. Problem number 2 here gives you a radius of 12 feet. Problem number 1 shows a diameter of 48 centimeters. So if I was going to actually solve for this one, the radius would actually be 24. I'll solve problem number 2 since it's sitting right here. So the volume here is pi times r squared. So that's 12 squared multiplied by the height of 19. Again, order of operations is important. You have to square prior to multiplying by h or multiplying by pi. I'll just show the step here. 12 squared is 144. So that's 12 times 12 is a gross then we can multiply these in any order. So I'll do that. Pi times 144 times 19. This gives me 8595.39. So I go 89, 85, 95. And then this is going to be feet by feet by feet, which is cubic feet. Okay? So there's your example for cylinders. Rectangular prisms. These are probably the easiest because you have no squaring or dividing. The volume of rectangles or cubes is just length times width times height. I'll pick the first one here. I'll go with problem number 2. These ones are all measured in centimeters. It gives me 40 centimeters by 29 centimeters by 53 centimeters. They can be multiplied together in any order because it's all multiplication. They're all centimeters. I don't have to worry about anything. So the volume here gives me 61480. And our units are cubic centimeters. So 61,480. Cubic centimeters, just like that. Next one's talking about spheres and hemispheres. So the volume for a sphere is equal to 4/3 pi r cubed. There's not a whole lot to it. For a sphere, there's really only one measurement because everything is perfectly symmetrical about the center of the sphere. So it's just the radius from the center of the sphere out to any part in the outer edge. Now again, problem number 1 gives you a diameter. So in this situation, the radius would be 24. And the other thing you'll notice is that this is a hemisphere, so it's half of a sphere, which means your equation for this would just be half of whatever this is. So there's two ways to look at that. Divide the 4 by 2, which would give you 2/3, or you could say it's 4/6. But I guess you'd probably go with the simplest fraction. We'll go with 2/3 pi r cubed for the hemisphere, because it's half of that. Or I guess deductively, at the end, if you got an answer, you could just divide it by 2. It would just be half of it. So I'll solve for the volume of this sphere, where the radius is 27. So the volume of this, they're showing 4/3 pi times r, which is 27, to the 3rd power. And that is to the 3rd power, it's not squared, so I'm going to take the 27 and go to the 3rd power, and that will give you a big number. It's certainly a large value, times pi, and then multiply that by 4/3. This gives me 82,448. And the units here are cubic centimeters. And a cubic centimeter is the same thing as a milliliter. So when you guys are doing the aluminum boat lab and they ask for volumes, I'll kind of talk a little bit about a method for how you can find the volume of your boat if you know how many milliliters of water you pour into it, because a cubic centimeter is the same thing as a milliliter. Okay? And let's see, finding the volume of a pyramid. Pyramids are 1/3 base times height also, very similar to a cone. However, the base of a pyramid is a square or a rectangle. It's not circular. So when we do 1/3 the base times the height, you really got 1/3 times the length times the width times the height. So they give you 3 measurements here. If this is the pyramid that I'm trying to solve for, I have 1/3 multiplied by 24, 8, 22. Order of operations here doesn't matter so much. I'm going to go multiply these 3 together. 22, 8, 24. Gives me 4224, and then divide by 3. Gives me 1408, I believe. And again, this would be cubic centimeters. Alright, so there's some examples on how to calculate the volumes of those. You guys do have some practice problems that you're going to do, again, on that digital copy, open it up, complete it, submit it back to me. If you have more questions on these, you can certainly email or stop down to ALC, or lots of resources online. I will put a couple of extra links in there for you guys to check out. Okay? Alright folks, so as far as the aluminum boat assignment, when you guys actually open up that document and make a copy for yourself, the introduction and so forth you can kind of read yourself. What I will do is I'll talk a little bit about the process of building the boat, making your hypothesis and the main concepts you're trying to get across. Then I'll give you guys some tips and hints on how to measure volume and mass at home if you guys do not have graduated cylinders and scales and so forth. So generally speaking, what you guys are trying to do is you guys are trying to build. Once you make your boat, you're going to have to try to make a hypothesis based upon the volume of your boat. So the whole concept here is how does volume or water displacement relate to the buoyancy force of an object? And generally speaking, I'm sure we kind of get the idea that a larger boat should be able to hold more mass than a smaller boat, but we want to look at it directly. How does the volume in milliliters pertain to the mass that the boat can support in, say, grams? So once you've built your boat, you need to try to figure out the volume before you can predict the mass. So here's my recommendations on trying to figure out the volume of your boat. When you guys try to figure out the volume of your boat, the easiest thing to do, if at home, if you have some sort of a measuring device, for example, just a measuring cup, it should have metric milliliters on there somewhere. If not, you could look at conversions for going from ounces to milliliters or cups to milliliters if you want, but that gets a little bit more confusing. But we definitely want the size of your boat in milliliters. So if you build a boat that is somewhat rectangular, this being an example of what's close to a rectangular boat, not perfect, but the little bit that you learned about volume, we should be able to just measure length and width and height of the boat, take those three dimensions in centimeters. As long as you measure in centimeters and you multiply it all out, a cubic centimeter is the same as a milliliter. So if I did that, I could get a general idea how large this boat is. Now, if I go and build something that's a little bit more elaborate or a different shape where it's rounded on the sides and tops, this, if you're trying to find the volume, mathematically would be kind of difficult. However, if I was going to fill this with water or using water displacement, I could figure out the size of this boat. If you're going to do that, just make sure that you place your boat or item inside of a container, something that's empty, because you're going to end up trying to pour water into it. So whether you use a measuring device like this, or if you actually have a graduated cylinder, you're going to fill it with water up to a known level, more than whatever the boat is. So for example, maybe I fill this up to 1,000 milliliters, and I'm going to slowly pour it into the boat until the boat is full, completely full, right up to the top. Like right when the boat won't take no more water and it starts to roll over the sides. And then look at the difference from 1,000 down to however much drained out. I went to 1,000 and I'm left with 600. I could conclude that the volume of the boat is 400 milliliters. So that would be another way to find the volume of your boat. When it comes to actually sinking your boat and finding the mass that it takes for the boat to be submerged, you have a couple of options. If you have some adamant objects at home, like maybe fasteners, bolts, washers, potentially some sort of metal, something that's uniformed, maybe a bunch of pennies, like rolls of pennies or something like that. When you put your boat in the water, you can use those number of pennies or coins or whatever it is to sink the boat, but you still need to somehow find the mass of those items. So maybe you have a scale at home, maybe you have a triple beam balance, something like that. If that's the case, it would be great. Bathroom scale probably doesn't work very well, but you might have like a kitchen scale that'll measure grams or ounces. You can definitely use those. If you don't have any of those, you can resort back to the measuring cup, something that gives you volume. 1 milliliter of water has the same mass as 1 gram. So you can sink your boat using water. If you float this, when it's completely dry, you can float it on the surface of the water, start with a known volume, and then fill up the boat until the boat reaches its maximum threshold for sinking. And sinking really is when the water kind of overtakes the side of the boat, is where you're going to consider it sunk. If you know how much water you poured in here before it sinks, that can also be a way to measure mass, because again, water has a density of 1 gram per milliliter. So if you know how many milliliters you pour in before the boat sinks, then you can figure out how many grams. So that's certainly another option for you. After you've made a hypothesis, so you've got the volume of your boat now, and you're going to make a hypothesis on how much mass it can hold, I want you to take some photos, take a couple of photos of your boat, give me at least a side view and a top view, and then maybe a view of the boat being sunk, or maybe the action of you sinking it, or something similar, and upload and add it to the document that we have. After that, you're going to just write a description as to how or why you designed your boat the way that you did, and then answer the conclusion questions. And that pretty much will summarize what you guys are doing with the aluminum boats. Hints and advice I can give you for design. I got a couple of examples here I'll show. So a couple of ideas for designs for your boat. Again, they don't need to be real elaborate, but these are all basic designs that you could construct. They don't require anything but aluminum foil. You can shape them round, square, whatever you want it to be. I do recommend trying to keep the design simple. Again, a square or box of some sort, rectangular prism, is a pretty good idea. One, it's easier to find the volume, and two, it again kind of conforms to the shape of a sink, like a kitchen sink, or the material that you're using. It folds up nice and square, and they perform just as well, because you should find out hopefully that displacement is key, and these boats aren't moving, so we don't have to worry about aerodynamics so much. But a couple of concepts to think about when you're sinking or building your boat. When you design your boat, strength is somewhat important. So aluminum foil by itself isn't very strong. So if you fold it and all the sides are flat, and you stack mass in it, it's possible that you could break through. So you may want to do multiple layers of aluminum foil. If you look at how a normal boat is designed, it's normally got ribs or seats or some sort of bracing that goes across the boat to make it more stable. You can definitely get intricate with the design of your boat, and you can put things like that in it. If you're building a large boat, you probably will need to or want to do that. If you're building a smaller boat, it might not be quite as critical, but I leave that choice up to you. Making sure your boat is somewhat balanced. It maybe doesn't matter as much when the boat is empty, dependent on the shape, but if your boat is wider than it is tall, when you put it in the water, it should be stable enough to not tip over. But as you start to add mass to it, you might put too much in one corner versus the other. The center of buoyancy is going to be around the center of the contact area with the water. So if your center of mass is higher than that, it's probably going to want to tip and topple over. But if the center of mass is lower than that, then your boat should be quite stable. So generally speaking, you want your mass centered and low relative to the sides of the boat. And remember, as your boat sinks, the water is going to come further and further up the side. So the center of buoyancy will go up as the boat goes down. But then as the boat goes down, the center of mass will be stronger. So the more weight you put in, as long as it's toward the middle or balanced, equally distributed, the boat actually becomes more stable. So just some hints. You guys can certainly choose whatever designs that you see fit.